In Lesson 7.2, we're going to talk about rotation. So a rotation is a transformation in which a figure is turned about a fixed point. So the center of rotation is that point with which you are turning. For most of these that we are going to look at today, we are going to be using the origin as the center of rotation. The angle of rotation is the angle formed by rays drawn from the center of rotation to a point and the image of that same point. So a figure in a plane has a rotational symmetry if it can be mapped onto itself by a clockwise rotation of 180 degrees or less. So most of the time whenever we talk about symmetry, what you're thinking of is line symmetry or reflectional symmetry, but also a shape will have rotational symmetry if you can spin it around and get to the original shape. So if you think about an equilateral triangle, it would have two measures of rotational symmetry, because as you spin it around, when you spin one vertex to match up with another vertex, it would completely copy over and you would be able to see all the same points. So when we talk about rotational symmetry, we can see if something has rotational symmetry by seeing if it can be spun around and you can get back to the same shape. So a rotation is also an isometry, because whenever you do the rotation, it's just in a new location, but all of the lengths and angle measures have been preserved. They'll all be the same. So first we're going to talk about these rules. So a 90-degree clockwise rotation. So if we're talking about clockwise and counterclockwise, it's important to actually think about a regular analog clock. So here's like a normal clock. You would have, your minute hand and your hour hand. And the way that the clock goes, like from 12 to 3 to 6, that is clockwise. Now, the opposite direction of that, like if you think about going from 12 to 9 to 6, like going backwards, that is counterclockwise. So when we're thinking about clockwise and counterclockwise, think about which direction are the points moving, and that would be going from the pre-image to the image. So when you are moving 90 degrees clockwise rotates to the right. So I like to draw this arrow above it, and 90 degrees clockwise, what that's going to do is it's going to grab this x value and move it to the back. And as it moves, just like in an equation, if you move something to the other side, it changes signs. So this is going to be y and then the opposite of x. So a 90-degree clockwise turn is a quarter turn to the right. So if you think about from 12 to 3, that would be a 90-degree clockwise turn. All right, a 90-degree counterclockwise, that's going the opposite direction. So here, if it's going 90 degrees, it's going to grab that y, and it's going to move it. So whenever that y moves to the front, it changes signs, and the x stays the same. So this is another quarter turn, but it's in the other direction. So a quarter turn to the right, a quarter turn to the left. 180 degrees clockwise is going to do both things. So it's going to move both of these twice. So it's going to change the signs, but not the locations. So think about if you're in the coordinate plane, it would move you from quadrant 1 to quadrant 3. It would go halfway around the center point. So this is a half turn either direction. It doesn't matter if you go clockwise or counterclockwise on a 180-degree rotation, because it's halfway. You're going to get to the same place no matter what. All right, next we're going to talk about a 270-degree clockwise turn. So I like to think about the clock whenever I'm thinking about these. So a 270-degree clockwise rotation is going to go 3/4 of the way around. So if we want to think about simplifying it and not having as many rules, a 270-degree clockwise rotation, the same result could be given by a 90-degree counterclockwise rotation. So this is going to be the same thing. You'll get to the same place as you would with a quarter turn in the other direction. So the same thing's going to be true for a 270-degree counterclockwise rotation. So if I go counterclockwise, that's going to take me from the 12 back around to the 3. But I could have gotten there quicker by going a quarter turn in the other direction. So I don't have extra rules to memorize for these. I'm just going to think about how could I get there going the other direction. So if I can just memorize these 3 rules, I have less to know. All right, so we're going to start with a 180-degree rotation about the origin. So first, let's get those ordered pairs from the original. So point J is starting at 1, 1. Well, 1, -1, because it's below the y-axis, or below on the y-axis. Point V is at 2, 0. Point Y is at 5, -3. And point R is at 4, -3. All right, so we're doing 180 degrees. That means like a half turn around the origin. So the origin is the center of rotation. So I'm going to take each point and I'm going to do a half turn around this circle. So like if I think about each one of these going a half turn around, where are they going to end up? So my circles are pretty rough here, but I also have the rule that I can go back to. So when we were working with a 180-degree rotation, we could go either direction, and what was going to happen is that both of the x and the y value change signs. So whenever it says -x and -y, think about it as the opposite of x and the opposite of y. So if I look at point J, the opposite of +1 is -1. And the opposite of -1 is +1. So point J, whenever I go halfway around that origin, would end up at -1, +1. So there's that result of that first half turn. So point V, if I do the opposite of each of those, the opposite of 2 is -2. The opposite of 0 is still just 0 because 0 is the middle of the number line. So this would be at -2, 0. That's halfway around the circle that would be created with the origin. So as I do it, I'm just going to take these really bad circles that I tried to draw and erase those. All right, so for point Y, the opposite of 5 is -5, and the opposite of -3 is +3. So this one is going to be at -5, +3. Don't know how I'm going to graph that one behind this toolbar. -5, +3. Oh, close. All right. I kind of know where it is. I just can't see behind my toolbar here. And I don't know how to make it go away on my iPad. All right, and finally, point R, the opposite of 4 is -4, and the opposite of -3 is +3. So -4, +3, also going to be behind that toolbar. Over there. All right, let me see, about right here. All right, so I'm just trying to do the best I can, working with what I have here to draw that line. Okay. So I know about where those are going to be. Should have done this one on my computer to show you a little bit better. All right. So -4, 3. Be like over here. There we go. Get it all right on estimating that one. All right, and then this one, -5, 3. Yeah, pretty good for not being able to see behind there. But this made a quarter turn around the origin, and I'm sorry, not a quarter turn, but a half turn around the origin to get those final points. So the rule for 180 degrees is going to be the opposite of x, opposite of y. All right, next we're going to rotate this figure 90 degrees clockwise around the origin. So first, I'm going to look at my original and write down the ordered pairs that go with it. So point M is at -1, 5. Point D is at 1, 5. A is at 4, 3. And W is at -1, 4. So for the rule, I think about what I'm doing. So I'm going 90 degrees clockwise. So that means in the same direction as a clock would go. So for a 90-degree turn, they are going to switch spots. So I draw that arrow up above to help me figure out what's going to happen. So the arrow starts at the X, so that's the one that's being grabbed and moved. So the Y scoots up and the X changes signs. So if I do this with my first point, I want to estimate where it's going to be. So if it starts at -1, 5, first I'm taking this X value and I'm moving it to the back. And whenever I do that, the sign changes. So this one will be 5, and then the sign will change to a +1. So if I plot this point and just look at its relation to the original, 5, 1. If I think about like making a big wide circle here, that is a quarter turn about the origin. So it's 90 degrees whenever you connect that point to the center of rotation. So 90 degrees from the original to the new point. All right, next let's rotate point D. So again, I'm going clockwise. So that'll be 5, -1 when I graph it. So 5, -1, this is the new version of point D. So if I look at the relationship here, from D to the origin and then D prime to the origin, those form a 90-degree angle. All right, so far with those 2 points, I have copied segment MD. Next, I'm going to rotate point A. So right now it's at 4, 3. So I'm going to grab that X value and move it clockwise. So that'll be at 3, -4. So whichever point is at the end of the arrow is the one that's moving and changing signs. All right, so 3, -4. And that is A prime. So if we think about point A and its relationship with A prime, we go back to the origin because that's our center of rotation, and that's a 90-degree angle. So it was 90 degrees, and it moved clockwise. All right, so now I'm going to connect D and A. All right, and finally I need to rotate point W. So I take that -1 and move it back. So this will be 4, and then that will change to a +1. So 4, 1 is here. So this is the new W. And then I can just observe that relationship and notice that it is a 90-degree angle. I did not mean to erase my label. All right, so that completes the rotation of that shape. So if I was a little bit more accurate, it would look a little better. My lines are a little bit thicker, so that makes it a little bit of an optical illusion. But the new figure is congruent to the original because this is an isometry. All right, on our last one here, we're going to go 90 degrees, but we're going to go counterclockwise this time. So this is the same pre-image that we started with last time. So M is at -1, 5. D is at 1, 5, A is at 4, 3, and W is at -1, 4. So this time I'm moving counterclockwise. So counterclockwise is the opposite direction of a clock. So if I think about that counterclockwise arrow, this one is grabbing the Y and moving it. So as I pull that Y up front, it will change and the X will just scoot back. So for this one, I'm taking my Y value and it's the one that's changing. So that 5 will change to a -5 and then the X value just scoots to the back. So this one will move to -5, -1. So again, I have a little bit of trouble when I'm going behind that toolbar. I think I did okay on that. All right, for point D, same thing. Take it and move it. So the 5 becomes a -5, and then that +1 just scoots back. So -5, +1. All right, for A, I'm going to move it around. The 3 is what's moving, so it will change signs. The 4 just moves back. So -3, 4. This one I can actually see from behind my toolbar. So now I'm going to look at that relationship. So we have a right angle, but this time we were moving to the left. So that 90 degrees is the center, is to the center of rotation. All right, our last point, when we switch it up, it becomes -4, -1. So -4, -1 is there. All right, so from behind, all of my points are behind my toolbar here. So I'm going to do the best I can to draw that shape. Oh, I didn't do so well. But on your Chromebooks, you'll be able to draw that a little bit better than I can on my iPad. But notice that everything moved to the left and it was 90 degrees to the left. All right, so the last thing we're going to talk about here is rotational symmetry. So if we think back to the definition of rotational symmetry, it said that a figure has rotational symmetry if you can match it up within a 90-degree clockwise rotation. So let's go back to that first page and look at that definition. So a figure has rotational symmetry if it can be mapped onto itself by a clockwise rotation of 180 degrees or less. So looking at these figures, what that means is that if I can take a point and if I'm spinning it like around the middle, so wherever the middle of the shape would be, if I think about spinning it around and it ends up exactly where it started, it would have rotational symmetry. So here, if I think about like these two particular segments, which are congruent, this is the only place where those happen in that order. So this one does not have rotational symmetry, because it would take a full turn to get back to the original. All right, now if I look at this one, at this equilateral triangle, so the two that surround it have these two markings. The next place that I would be able to get this is here at this second mark. Then I would get another place of rotational symmetry once I got around to this mark. And then with one more, I would be back to the beginning. So to figure out these degrees, I think about how many total places I marked. So here I had 3 spots where it had rotational symmetry. So think about a full circle. That's 360 degrees. I'm going to take 360 and I'm going to divide that by the number of points where it had rotational symmetry. So 360 divided by 3 is 120 degrees. So the first place where it matches up is at 120 degrees. The second place where it matches up is at 240 degrees. And then we get back to the beginning at 360. So to find the degree of rotational symmetry, you would take 360 and divide it by how many times you would have to turn it. All right, so we're going to pretend like this one is all equal. So it's a rough drawing, but if I look at it, once I get this top point over to map on top of this second point, that would match up and be the same. Then I have another point where it can rotate, and another point, and another point. So this one, there are 5 different places where it can match up. So to figure out the degree of rotation, I'm going to take the full circle, and I'm going to divide it by the number of points that match up. So 360 divided by 5. So whenever I divide that, I get 72 degrees. So that means that each of these points are 72 degrees away from each other. So this interior angle here is going to be 72 degrees, each one of those. So I can find the measure of each of those points by counting up by 72. So the first point would be 72 degrees away, and then 144, and then 216, and then 300 and nope, sorry, not 300, 290 degrees. That's not right either. All right, so 288. So then finally we end up back at 360. So each time I was just adding on 72 to find those different places where it matched up. All right, so on this last one, I have to choose a point. This one is where a side that's marked with 1 marking meets a side that marks with 2 markings. So the other place I see where this happens is down here. So once I get here, it's kind of like it rotated over, and then I have another one. So to find this angle of rotation, there were 2 places. So this is going to be a 180 degree rotation. So if I think about from the center, from one to the other is 180 degrees. It's half of a circle.